Section 9.2 is going to be function notation and linear functions. So starting with function notation. So far, if you think back to when we've been working with equations, we had a independent variable x and a dependent variable y. So instead of using y, we can use function notation, and we often use letters such as F, H, or G. We can use capitals if we want also. So the idea here is we're going to be using something that looks like this. Instead of y, we're going to turn that into f of x, and we read that just how I read that. We read it as f of x. So this means that f is the function, and we know that since there's an x written there, it is a function where x is the independent variable. Okay, so let's do an example where we evaluate some of these functions using this notation. So if we have f of x equals x squared plus 3x plus 5, and we want to evaluate f of 2, so instead of having f of x, we now have f of 2. So this means that x equals 2. So we're trying to find the function values, or the y values, when x equals 2. So it's relatively simple. All we have to do here is plug this in. So instead of the x's, we have 2. It's going to be 2 squared plus 3 times 2 plus 5. That's going to give us 4 plus 6 plus 5, which is going to give us 15. So this means that f of 2 equals 15. So we could write this as an xy coordinate if we want. We would write this as, or 2 comma 15. Okay, next one we have f of negative x. Scroll back up to see the function. So f of negative x is going to be everywhere we see a x in the original, we're going to plug in a negative x. So instead of x squared, it's negative x squared. So make sure that you have parentheses. Plus 3 times negative x plus 5. So we have negative x to an even exponent. Whenever that happens, negative to an even exponent, the negative cancels off. This is just going to be positive x squared. And then minus 3x plus 5. Okay, so this one's a little bit different because we have x's still, which is fine. We can plug in variables back into the other variable. The other one we got a value out, which could be thought of as an xy coordinate. And next one is going to be even more complicated. We have f of x plus 3. So everywhere that there is an x in the original one, we're going to plug in an x plus 3. So if we're looking at the original here, instead of an x, we're going to plug in x plus 3. And instead of an x, it's going to be x plus 3. So this is going to be x plus 3 squared plus 3 times x plus 3 plus 5. So instead of an x, it turned into x plus 3. Okay, so what we have to do is we actually have to expand out the x plus 3 squared and then distribute that 3 in the second big term. So x plus 3 squared, hopefully we can do that in our head. If you can't, you have to write it out like this. And then you have to distribute, or FOIL. We would get x squared plus 6x plus 9. So that whole first portion becomes x squared plus 6x plus 9. Distribute that 3, we get 3x plus 9. And then plus that 5. Combine like terms, we get x squared plus 9x plus 23. And that is our f of x plus 3. Okay, so let's do another one. Do 2 more to make sure we're comfortable with this. So like we did in the previous one, part B, when I did f of negative x, I'll put a little note up here. If you have a negative x to an even power, you can drop the negative and it becomes x to whatever that even power is. Because if we have an even power, that means the negatives are going to group up in pairs and they're going to multiply to a positive. If you have a negative x to an odd power, there's always going to be one leftover negative. So the parentheses get dropped, but the whole thing is still negative. Okay, so that's pretty important, a good shortcut for doing these. So let's do f of x equals x cubed minus 2x minus 1. So all we have to do here is plug in a -3 into all of the x's. That's -3 cubed minus 2 times -3 minus 1. So -3 cubed is -27. And then plus 6 minus 1, which gives us -22. So f of -3 equals -22. So once again, you could write that as an xy coordinate if you want. That corresponds to the coordinate -3, -22. And then for this last one here, f of -x, we plug in a -x everywhere there's an x. We get -x cubed minus 2 times -x minus 1. And now simplifying this, -x to an odd power, it stays negative, parentheses dropped. And then negative times a negative, we get plus 2x minus 1. So this gives us f of -x equals -x cubed plus 2x minus 1. Okay, we'll do one more here. So we have g of x equals -x squared plus 10x. And we want to evaluate g of 5. So plugging in a 5, we have -5 squared plus 10 times 5. So -5 squared, PEMDAS exponent first, that's -25 plus 50. That gives us positive 25. So g of 5 equals 25. Next one, g of -x. So plugging in a -x everywhere, that's going to be -x squared plus 10 times -x. So -x squared is positive x squared because it's an even power, but there's still that negative out front, so it's -x squared and then minus 10x. So that's g of -x, and then lastly we have g of x plus h. So once again, a little bit more complicated. Everywhere there is an x in the original, instead of g of x, it's going to be g of x plus h. We're going to plug in an x plus h everywhere. So this is going to become -x plus h squared, and then it was plus 10x, so that's going to become plus 10x plus h. So when we are figuring out how to expand this x plus h squared, you might have to, maybe you can do this in your head, you might have to write it on the side. When you're expanding this out, you're going to end up getting, so you're foiling it, x squared plus xh plus xh plus h squared. So you get x squared plus 2xh plus h squared. So we still have that negative in front, so I'm going to leave it out front like this with parentheses and rewrite this for what we just found. And then let's distribute that 10. So plus 10x plus 10h. And now we have to distribute that negative, so it's -x squared minus 2xh minus h squared plus 10x plus 10h. And there's actually no like terms here, so we have to leave it just the way it is. And that is our g of x plus h. Okay, so pretty messy, but still doable. So the next thing is graphing linear and constant functions. So this is kind of an overlap of stuff we've already done, except now we're going to be using this function notation. So any sort of linear equation except for vertical lines, which have an equation of x equals a, where a is a number, are going to define linear functions. So instead of writing the function as y equals mx plus b in slope-intercept form, we can write it as f of x equals mx plus b. So once again, this is instead of using y, and this is in slope-intercept form. So we should know how to graph this. We can, where b is the y-intercept, m is the slope, we can graph it by plotting the y-intercept and then using the slope to find the second point, connect them as a straight line, put arrows on the end. And we also know the domain of a linear function is all real numbers, so negative infinity to infinity, meaning we can plug in any x value and it will give us a y value out. Okay, so a function in the form f of x equals b, so there's no x here, so this is f of x equals a number. This is going to be a horizontal line. So this is the same thing as like y equals 4. We know those are horizontal lines. Those are called constant functions. The domain is negative infinity to infinity, and the range is b. So the range of a horizontal line is just going to be that horizontal line's value. Okay, and then something that's added in real quick. Going back up here, the range of a linear function is also going to be negative infinity to positive infinity. Okay, so let's just do a couple more examples here of graphing. Once again, we've already done this. So we have f of x equals 1/4 x minus 2. So we have a y-intercept of negative 2, a slope of 1 over 4. So when we graph this, we go to the y-intercept, we go to the slope, up 1 to the right 4, connect them, and that is our line. So we can label this just by writing f of x. We don't have to write the whole thing because it has a function name. So this question also wants the domain and range. So since this is a linear function, both of these domains and ranges are going to be negative infinity to infinity. We can also tell from the graph that these would be the domain and range. Okay, next one, g of x equals 3. So this is going to be a constant function. So for this one, we have a slope of 0. If you have to write it out, we have a slope of 0 and a y-intercept of 3. So it's a constant function, so all we have to do is go up to that y-intercept and draw a horizontal line. So we already knew that this was going to be a horizontal line because it's the equivalent of y equals 3. So we just go up to 3 on the y-axis and draw a horizontal line. And then we can label this as g of x. So we're never going to have a vertical line in function notation because those are not functions because they fail the vertical line test. Okay, and then the domain and range for this, the domain is going to be, you can tell by the graph, is negative infinity to infinity. The range, though, is only going to be that value of 3. So you write these with the squiggly brackets. It's just one number and it's just 3. That's the only y value where it exists. Okay, so I only have these two examples for this because once again, we've already done these with just using a y instead of the function notation. But going forward, we'll be using the function notation. Okay, so that's it for this section.